Stop. Before you pull that dying plant out of the ground, look at it one more time. That tomato plant with paper brown leaves, that pepper that stopped flowering weeks ago, it is not dead. It is starving. Soil scientists who study the exact moment a plant begins to die have found something remarkable. In almost every case, that plant is missing just one or two nutrients, and every single one of those nutrients is already sitting inside your kitchen. Right now, waiting to be used. 5 fertilizers. Zero cost. Some of them start working in as little as 48 hours. Amish farmers have used them for generations. University soil labs have measured them. And the fertilizer industry has quietly ignored them. For one simple reason, there is no profit in a banana peel. Here are the 5 secrets hiding in your trash can. Here's a question worth asking before another onion skin lands in the trash. Which part of the onion actually holds more potassium? The white bulb that goes into your soup? Or the dry, papery brown skin you peel off and throw away? Most people guess the bulb. The answer is the skin, those thin brown layers, the ones treated as garbage in kitchens everywhere, carry one of the most concentrated doses of potassium, calcium, magnesium, and iron found anywhere in the produce aisle. They also carry a compound called quercetin, the same antioxidant that makes red wine, apples, and blueberries good for the human heart. Inside a plant, quercetin does similar protective work. It shields leaves from harsh summer sun. It slows the spread of fungal disease. It steadies the plant's internal chemistry when a heat wave or a cold snap rolls through. Here's where most home gardeners make the wrong move. They hear about onion peels, and they bury the skins straight into the soil, expecting them to break down and feed the roots. That method works, eventually, but it takes weeks. And a wilting plant does not have weeks. The real trick is water. Water pulls nutrients out of plant tissue the same way a tea bag releases color into a hot cup. Drop a handful of dry onion skins into a quart jar of cool tap water. Let it sit at room temperature. That's the entire setup. Within a day, the water darkens to the color of weak tea. By the second day, it deepens to amber. That color is not a coincidence. It's potassium, calcium, magnesium, and quercetin leaving the plant tissue and dissolving directly into the liquid. Already in a form the roots can absorb immediately. One gardener in Ohio tried this on a pepper plant that had stopped setting fruit for nearly 3 weeks. She poured a cup of onion peel tea at the base, once every few days. By day 6, new flowers had opened. By day 10, the first peppers were forming again, poured at the base of a yellowing tomato. This amber liquid often works within days. Stems thicken. New leaves come in a deeper green. Flower production picks up. And here's a detail most gardening blogs leave out entirely. The plant's own immune system starts fighting harder. Stemrot slows. Seedling with fodis. The plants that would have been pulled out by the weekend are still standing at the end of the season. And here's the part no fertilizer label will ever admit. No company can build a business around onion peel tea. There's no way to package it. No patent to file. No shelf space to sell. That is the real reason this method quietly disappeared from mainstream advice. Not because it works less, but because it cannot be sold in a box for $9. Onion peel tea feeds the plant directly, but the next method doesn't feed the plant at all. It feeds something far more important: the billions of invisible workers living in the soil beneath it. What if the cloudy water you pour down the drain every evening, the leftover liquid from rinsing a pot of uncooked rice, turned out to be one of the most powerful soil treatments ever studied under a microscope? It sounds like an exaggeration. It isn't. Fresh rice water, straight from rinsing, carries starches, B vitamins, and small amounts of iron and zinc right out of the pot. It's already mildly useful to a garden, but the real transformation happens a few days later. Leave that water in a covered jar at room temperature. and within a few days the liquid takes on a faint sour smell, something close to the first hint of a sourdough starter. Most people would pour it out right at that stage. Doing so throws away the most valuable part. That sour smell is the signature of a microbial bloom. Lactic acid bacteria and wild yeasts have moved in and taken over the liquid. This is where the work of a Japanese agricultural scientist, Dr. Teruo Higa, becomes important. Back in the 1980s, Dr. Higa introduced the concept of effective microorganisms, beneficial microbes that, when added to depleted soil, could bring it back to life within weeks. His formulas are now used on farms in more than 150 countries. And the same microbes at the heart of those formulas appear naturally for free. In fermented rice water, here's what happens underground. Once this liquid touches a garden bed, the bacteria and yeasts meet the microbes already living around the plant's roots. The starches and sugars in the rice water act as a feast. The soil microbiome wakes up, multiplies, and gets to work. Within a single week, the population of beneficial microbes around a treated plant can triple. 1 teaspoon of soil after this kind of treatment can hold more than 1 billion living organisms, more than the population of North America, packed into something smaller than a coffee bean. This is the moment the idea clicks for most gardeners who try it. Rice water doesn't feed the plant directly. It builds the plant's entire support system. It's the difference between handing someone a single meal and handing them a working kitchen. A meal runs out. A kitchen keeps producing. A gardener in Texas started pouring fermented rice water around a struggling rosebush every week, just to see what would happen. By the 3rd week, the soil around the roots looked darker, looser, almost alive to the touch. New growth appeared where the plant had been stalled for over a month. Now, the mistake nearly everyone makes the first time. They pour the water on fresh, straight from rinsing the rice. Fresh rice water does something, but very little. Fermented rice water, 3 to 5 days old, is an entirely different tool. The smell is the signal. No sour tang means it isn't ready yet. One more rule matters here. Fermented rice water should be diluted at about 1 part rice water to 10 parts plain water before it touches the soil. Undiluted. The acidity can irritate tender roots, especially in seedlings. Diluted correctly, it's gentle enough to apply weekly all season long. Rice water rebuilds the soil's living foundation. But a plant collapsing today can't wait for soil to rebuild itself. That plant needs food it can drink before sundown, which is exactly why the next method exists. Every refrigerator in America has one. The forgotten tomato sitting at the bottom of the crisper drawer, the head of lettuce that wilted before anyone got around to using it, the bruised cucumber pushed to the back of the shelf. For most households, these scraps end up in the trash, or at best in a compost bin that won't produce anything usable for another 6 months. For a gardener who knows the method, those same scraps are the fastest acting nitrogen source you can make at home. The science behind this goes back to the 1840s, to a German chemist named Justus von Liebig, one of the founding fathers of modern agriculture. Liebig proved something that changed the way farmers thought about soil. A plant's growth, he showed, is not determined by the nutrients it has plenty of. It's determined by the one nutrient it has the least of. This became known as the law of the minimum. Picture a wooden barrel built from staves of different heights. The water inside only rises as high as the shortest stave. It doesn't matter how tall the rest of the staves are. One short stave caps the whole barrel. Plants work the same way. A tomato plant might have generous potassium and plenty of phosphorus, but if nitrogen runs short, growth stops right there, at the nitrogen line. No matter how rich the rest of the soil is, and in nearly every American backyard garden, nitrogen is the single most common missing stave. Green kitchen scraps carry what soil scientists call a low carbon to nitrogen ratio. In plain language, they're packed with nitrogen compared to their fiber content. Overripe tomatoes, soft peppers, wilted spinach, bruised kale, old cucumbers. All of them are nitrogen in disguise. Here's the method. Crush the scraps into a 5-gallon bucket. Cover them with water. Weigh them down with a plate so they stay submerged. And let the mixture ferment for about 2 weeks. Bacteria in the water break the plant cells apart, releasing the nitrogen locked inside the tissue straight into the liquid. Soil scientists call this process nitrogen mineralization. And in water, it happens far faster than it ever would in a compost pile. The finished liquid isn't pretty. It's dark, cloudy, and strong-smelling. Earthy, pungent, unmistakable. That smell is the proof it's ready, diluted at about 1 part scrap liquid to 30 parts fresh water. This digestate goes straight onto the soil at the base of the plant. Within 4 to 6 days, the change becomes visible. Pâle. Tired leaves deepen into full shades of green. New shoots push out from leaf joints where nothing was forming before. Stems thicken near the base. A plant that looked finished on a Monday can be setting new flowers by the following Saturday. A gardener outside Atlanta tried this on a row of kale that had stalled for weeks in the summer heat. 5 days after the first feeding, the leaves had turned from pale yellow-green to a deep, glossy green, and 2 new plants had sprouted side shoots they hadn't shown all season. Now, the mistake that burns more gardens every summer than any other. Excited gardeners often pour this liquid directly onto leaves as a spray, or apply it undiluted at the roots. Both are a disaster. The liquid is strong enough to scorch leaves on contact, and undiluted, it can burn root hairs beyond recovery. This method belongs at the soil, at the correct dilution, applied to the root zone, never stronger, never on the leaves. Here's the quiet truth most home gardeners never realize. The average American kitchen produces more nitrogen in a single week than a small vegetable garden actually needs in a month. The nutrients were never scarce. They were simply being routed to the landfill instead of the garden bed. Nitrogen solves the hunger problem. But most collapsing plants aren't missing just one nutrient. They're missing 5 or 6 at once, in different amounts, all at the same time. For that kind of rescue, one ingredient isn't enough. The garden needs a full recipe. Every struggling plant has its own combination of deficiencies. So, what if there were one single mixture, built entirely from items most households throw away before breakfast, that covered almost all of them at once? That mixture exists. It comes together like a recipe, with each ingredient doing a specific job. Understanding what each one actually does is the difference between a tonic that works a little and a tonic that can save a plant overnight. Start with 3 familiar items pulled straight from the kitchen counter. Banana peels provide potassium, the mineral that drives flowering, fruiting, and a plant's ability to move water through its cells. A tomato plant short on potassium produces small, watery fruit with skins that split as they ripen. Finely crushed eggshells provide calcium carbonate, the building block of cell walls. Calcium deficiency is behind one of the most frustrating sights in a tomato garden. The black, sunken patch at the bottom of an otherwise beautiful fruit, known as blossom end rot, and used coffee grounds, the kind left in the filter basket after brewing. Add a slow release of nitrogen and improve the texture of the soil. Here's a point where a lot of gardening advice online is simply wrong, and it's worth pausing on. For decades, gardeners have been told that coffee grounds make soil more acidic. That's a half-truth stretched into a full myth. Fresh, unbrewed coffee grounds are indeed acidic, but used grounds, the kind that come out of a home coffee maker, sit nearly neutral. University soil labs place them between 6.5 and 6.8 on the pH scale. Almost exactly where most vegetable gardens want to be. Used grounds won't dramatically acidify a garden bed. What they will do is add organic matter, feed earthworms, improve drainage, and release nitrogen slowly over several weeks. 2 more ingredients take this recipe from good to exceptional. The first is Epsom salt, technically magnesium sulfate. Magnesium sits at the exact center of every chlorophyll molecule in every green leaf on Earth. No magnesium, no chlorophyll, no chlorophyll, no photosynthesis. When magnesium runs low, leaves begin to yellow between the veins, while the veins themselves stay green. A pattern called interveinal chlorosis. 1 tablespoon of Epsom salt dissolved into the brew delivers a direct magnesium boost that can reverse this pattern within days. A quick caution belongs right here, because this is where well-meaning gardeners get into trouble. Yellowing leaves can have many causes. Nitrogen deficiency yellows the older leaves first. Iron deficiency yellows the youngest leaves. Overwatering and root rot can yellow the whole plant. Epsom salt fixes magnesium deficiency specifically. When that's the actual cause, the change is dramatic. When it isn't, adding more Epsom salt won't help, and may even throw off the soil's balance. Diagnose first, then treat. The second specialty ingredient is blackstrap molasses. Not the regular kind, the dark, almost bitter version from the final boiling of sugarcane. Blackstrap is rich in iron and trace minerals. But its real role here is something different. Molasses is food for microbes. A tablespoon stirred into the brew is like ringing a dinner bell for every beneficial bacterium in the liquid. Their populations multiply within hours, breaking down the banana peels, eggshells, and coffee grounds far faster than the ingredients would decompose alone. A brew without molasses takes 3 weeks to be useful. A brew with molasses can be ready in 3 days. A gardener in North Carolina mixed this exact brew for a row of struggling peppers that had stopped growing in midsummer heat. 4 days later, new leaf growth had returned, and the plants that looked stuck for weeks were finally pushing upward again. All of it. Banana peels, crushed eggshells, used coffee grounds, Epsom salt, and blackstrap molasses. Goes into about 1 gallon of warm water and steeps for 3 to 5 days in a covered bucket. The result is a full-spectrum tonic carrying potassium, calcium, nitrogen, magnesium, iron, trace minerals, and a live culture of working bacteria, all in one pour. The one mistake almost everyone makes here is skipping the molasses. Without that microbial catalyst, the peels and shells release their nutrients slowly, week after week. With it, the release happens in days. That single tablespoon is the difference between a slow-drip fertilizer and an instant rescue. This recipe covers everything sitting in a modern kitchen. But there's one more method older than any of these ingredients. Older than coffee and bananas in American grocery stores. Older than most of the houses in the towns where this video is playing. A method used by every civilization that ever grew its own food before 1913. Synthetic fertilizer didn't exist. Every farm on Earth, from Iowa to Ireland to the foothills of India, ran on the same 2 inputs, animal manure and compost. Then a German chemist named Fritz Haber, working alongside an engineer named Karl Bosch, invented a process that pulls nitrogen straight out of the air and turns it into ammonia. That invention, now called the Haber-Bosch process, is often credited with feeding half the human population alive today. It's also quietly the process that stripped the life out of cropland across most of the industrialized world over the following century. Synthetic nitrogen fed billions of people. It also taught farmers to feed the plant while starving the soil beneath it. For a home gardener trying to save one struggling plant in a backyard, the old method still works. And it still outperforms the synthetic version. This method is called manure tea. Old-time farmers in the Appalachian Hills and the Pennsylvania countryside have another name for it, the giant tea bag. The setup is as simple as anything on this list. A shovel full of aged, dried manure, chicken, chow, or rabbit, never fresh. goes into a porous sack. An old cotton pillowcase works. So does a burlap feed bag or a mesh laundry bag. Tie the sack shut at the top and drop it into a 5-gallon bucket of water. Over the next 3 to 5 days, the water slowly draws out the soluble nutrients: nitrogen, phosphorus, potassium, and a long list of trace minerals, leaving the solid matter safely inside the sack, where it won't burn the garden or carry weed seeds into the beds. Each kind of manure brings a different profile, and choosing the right one matters more than most people realize. Aged chicken manure carries the highest levels of nitrogen and phosphorus of the three, making it the most powerful growth stimulant. A single cup of chicken manure tea, properly diluted, can push a tired tomato plant back into heavy flowering within a week. Cow manure is more balanced, lower in nitrogen, but exceptional for building long-term soil structure. Rabbit manure is the quiet secret of experienced gardeners. It's the only common manure mild enough to apply without burning roots, which makes it the gentlest option and the safest choice for young seedlings. Here's the mistake that kills more manure tea gardens than anything else: using fresh manure. Fresh droppings carry too much ammonia, along with weed seeds and pathogens from whatever the animal was eating that week. A single bucket of fresh manure applied too generously can scorch an entire row of seedlings within 2 days. The manure has to be aged, ideally for 6 months to a year, before it ever goes into the bag. There are no shortcuts on this step. Once the tea is brewed, dilution becomes the next decision that matters. The finished liquid should be diluted down to the color of weak iced tea, roughly 1 part tea to 10 parts clean water, before it ever touches the garden. That ratio isn't a guess. It's the line between a tonic that heals and a tonic that burns, applied at the right strength. A single cup poured at the root zone of a tomato plant can keep it thriving for a full week, sometimes longer. One more detail. Old-time farmers swear by sixth ever, end of use X24. And modern soil science now backs up manure tea works best applied in the cool hours. Early morning, or the last hour before sunset. In the heat of midday, much of the nitrogen evaporates before the roots can absorb it. In the cool of evening, the soil holds onto the nutrients, and the plant drinks at its own pace. Overnight, a gardener in rural Vermont kept a bucket of aged cow manure tea going all season for her flower beds. By midsummer, the roses that had looked thin and pale in spring were thick with blooms, holding their color long after the rest of the yard had faded in the heat. The final result is a fertilizer that combines every essential nutrient a plant needs with the living microbes that help the plant actually use them. It's a full ecosystem in a single bucket, and it costs nothing beyond what the animals have already provided for free. 5 fertilizers, 5 methods, every one of them already sitting in your kitchen, your garden, or your shed. Onion peel elixir, fermented rice water, vegetable scrap digestate, the kitchen cocktail, aged manure tea. Each one costs nothing. Each one begins working within a week, sometimes within 2 days. And what ties all 5 together is this: the things you call waste are, almost every single time, exactly what your garden needs to come back to life. So the next time a tomato plant starts to yellow, or a pepper stops setting fruit, or a proud old rosebush begins to fade, pause before you reach for the shovel. The cure is very likely sitting in your trash can right now. If any of these 5 rang true, tell me below which one you're trying first. Share this with someone who's lost more plants than they've saved. And subscribe, because the next dying plant you save might be the one in your own backyard.